Hello, everyone. I'm John Vinsel. I'm a program manager on the Windows developer team. Here to talk to you today about application security and deployment. So let's start off today and talk a little bit about what is code signing. For Windows, code signing is based off the MS developed standard, which is called Authenticode. And that Authenticode standard really leverages PKCS signature format combined with the X509 certificate format. And then we use that working with certificate authorities that are the ones that issue the certificates to people that need to sign applications. What the certificate authority will do is they'll actually go and verify that the requester of the certificate is authentic and issue a certificate based on their identity. And these certificate authorities are all part of a standard program that's the Microsoft Trusted Root certificate program. So a lot of people come and ask, why do I want to go and sign my code? It boils down to a couple different things. Code signing establishes the integrity of a file. We can tell if a file has been changed or tampered because that code signing signature will no longer be valid if the file has been changed. But it also establishes the authenticity of the file so that you know that the source is coming from is actually who it's coming from, and it's not being distributed from someone that you don't know. In addition to establishing the integrity of it and authenticity of the file, you can also use it for things like code authorization. And this can be done through various things like CI policies. For example, Windows 10 in S mode leverages a very locked down CI policy to only allow apps to be installed from sources like the Microsoft Store. So a lot of people come to me and they say, hey, why can't I just self-sign my certificate? And really that boils down to there is really no authentication of the author. The best example of that is it's really just like a fake ID. You can say whoever you are, and there's no one to validate that you really are who you are. So when we talk about authorization based on code signing, there's different levels of trust that can happen. There's the generic certificate that can be purchased by anyone and is along the lines of the least trusted or the lower trusted. Now that certificate is still, the CA authority is still validating that the person is who they are that's requesting the certificate. But it's just a little bit less trusted because it's not a larger vetting process. Then we have these things called EV certs or extended validation certificates. And these go through a lot more vetting to get issued. And they usually offer a longer level of trust. And then for certain scenarios, things like, UFI or, the Windows Store, there may be additional validation that needs to occur before the app is authorized and loaded in certain scenarios. So one of the bigger challenges customers see with certificates in general is certificate security. And it's really about protecting that private key. The most common mistake or the most common challenge people have is storing that private key directly on a developer machine. And the reason that's a bad thing is that can get compromised and stolen, and then people have actually stolen your identity. They can go and sign apps on your behalf, and then basically impersonate who you are. Better solutions that people use for code signing are leveraging things like smart cards or YubiKeys, or even more secure using things like Azure Key Vault, leveraging the Microsoft Store, or using Azure Trust Service, which I'll talk about a little bit more later in the session. So in addition to all this, we've gotten some feedback from developers about really, how do you guys kind of see code signing? And, the first thing they really say is, all the trouble it takes to code sign isn't, really worth the hassle to them. They're concerned about the costs in acquiring certificates. And then most importantly, like I talked about, making sure that's securely stored, and how do you integrate it into something like a CI/CD pipeline for continuous integration, and do that in a secure fashion, because you don't want to store your file just on a server where it can go get compromised. And then lastly, just getting and maintaining that certificate, with expiration and updating of all that is really kind of cumbersome, and just causes more issues in your development lifecycle. So that's really where the Azure Trust Service is going to come and help us. The Azure Trust Service is a code signing service that Microsoft is going to be offering, and it's going to provide proof of integrity and authenticity for you as developers signing applications. The best part about the Azure Trust Service is we will be managing the keys within our infrastructure. So there's nothing for you to have to go in go and focus and put the keys within your infrastructure, we'll store those securely. And then what you'll do is you'll do a request and go in, sign against the service. It's a similar type of experience that you'll have if you leverage our Microsoft Store, where we issue keys on demand for signing requests. So all in all, this is one of the things we want to do to make it easier for you as developers to go and sign your codes, but also another way to make it easier for IT pros to deploy things like Windows Defender application control. When I talked about limiting the code signing, experiences, a couple slides ago. The, overall, we really want to build upon infrastructure and knowledge that we have. So, the Azure Trust Service is really building upon Microsoft's proven expertise in code signing. We code signed billions of files a day through all the different Microsoft products and services that we use, whether it's building Windows through Office, through the Microsoft Store. And what we're looking to do is really make this super easy to integrate into your existing workloads, whether it be Visual Studio, Azure DevOps, or any kind of experience that you have for building and deploying apps. So instead of me just continually talking about what the Azure Trust Service is, I think the best example of this would be to actually take you through a live demo of building and signing an app through the Azure Trust Service. And my peer Scott is going to help us with that.
All right. Thanks, John. Hey, everybody. For this demo, I'll be showing how a third-party developer might integrate with Azure Trust Services to enable code signing as part of their CI/CD or release pipeline. I'll be triggering a release workflow in my GitHub repository, which builds a simple Windows application and packages it as an MSIX installer. This workflow invokes a custom GitHub action that signs the MSIX installer using Azure Trust Services. First, though, I'd like to show I have a version of my application on my machine here that is not signed. And as you can see, it's not trusted, and I'm not able to install it locally. So now I'll switch over to Visual Studio, and I'm going to trigger a release workflow by pushing a tag to my remote repository. Now, there are a number of ways that a workflow like this could be triggered, including pull requests or automated daily builds. This is just one simple example. Okay, now my tag is pushed. If I switch over to my repository on GitHub and I navigate to the Actions tab, we can see here that my workflow has been triggered and it is currently in progress. This workflow is going to build my application, package it, and then sign it with our custom GitHub action using Azure Trust Services. Now, while this builds, I'd like to note that there are no code signing certificates or private keys to manage or deploy in order to run this action. Private keys are securely created by Azure Trust Services and never exported or exposed outside of the service. Certificates are issued dynamically per signing request by our issuing CAs, and when signing is complete, the certificates and private keys are no longer needed and are removed from our service. Now, I'd also like to show here a simple example of how the code signing action would be invoked in a GitHub workflow simply by adding the highlighted GitHub action YAML fragment and providing values for an onboarded identity as well as the file to be signed. Okay, and I'll switch back to this build, and we'll fast forward through this as it'll just take a couple of minutes. Okay, as we can see here, the signing step was successfully run. And now that this workflow is completed, the signed application is published to the repository's releases page, where it can be then downloaded and installed. So let me just browse there so we can see the latest release. And we can download the application. As you can see here, this application is now trusted. and we are able to install and run the application.
Awesome, Scott. That was a great demo of showing us how you can use Azure DevOps integrated with the Azure Trust Service to sign your MSIX package. And for folks watching this session, we're going to have a preview this summer of 2020 that you can start testing and experiencing what the Azure Trust Service is. So building upon that demo, one of the things that we kind of showed you was building an MSIX package. And since the session is really about application security and deployment, we want to talk about how you can leverage all the fundamentals of code signing and then use that within a modern deployment technology. So when we look at MSIX, it's really all about taking the developer feedback of, hey, how can I take my application and make it more reliable and provide integrity on it so that I know that I'm going to have a simplified and easy to use app deployment. Most important in all this scenario, how can I do it with the existing assets I have? I don't want to have to start over from everything. I already have good code, a good app that works. Can you make it really easy for me to go and update my installer? And MSIX does that for you. In addition to that, it also provides you easier ways to update your application by providing most of that functionality within the OS platform. So when we went to look at MSIX, we actually looked at a whole bunch of different technologies that Microsoft offered over the years and what customers are using. Things from like setup.exe to MSI to ClickOnce, even to PowerShell scripting. There's lots of different ways people go and deploy applications, and we really tried to pull the best experiences from those and try to leave the things behind that cause the most problems. And that really helped us evolve into what is MSIX. And MSIX should be the superset of all these deployment technologies, trying to bring the best parts of these technologies forward for you to really bring that simplified application deployment forward. So what are the things that we kind of look at for MSIX? Plain and simple, it's just a simpler packaging and deployment technology. The application installation is declarative and it's driven from a manifest file. So you can easily understand every single thing that the application is doing when it installs. Also, with the packaging format, we've instituted a formal identity and versioning system and built-in device targeting. So everything that's declared in the manifest helps build your identity of your app and how it's applicable for the OSs that you want to deploy to. And I'll dive a little bit more into that identity in a couple slides. OS managed. With existing installers, you have to think about all right, what were my previous versions of the app? Do I have to go and install them? Do I have to migrate that app data over? Windows takes care of all that for you. We do the install, we do the update, we do the removal of the app. And we also make sure that app state is stored in a known good location that's specific to the users because the apps are installed per user, making it easier to go and roam data as needed. Or also, in a more subscription-based licensing, it makes it easier to focus on per user installs for that user that the app is actually licensed for. And then lastly, Windows provides integrity for the application. Leveraging the things that we talked about, code signing combined with the block map, we know that the files that are laid down on disk are the ones the developer intended. So at any point, if anything is ever changed or altered in that app, we know that and we can take action on that to make sure that the user's app is never compromised. So let's dive a little bit more into what an MSIX file is. First off, let's just kind of look at the basics of what's the file there. There's the package payload, which is all your files that make your app run. And then there's some accompanying footprint files that I'll kind of walk you through. Everything we need is inside the MSIX package. And at the end of the day, the MSIX package is just an OPC container or, kind of like a zip file to make it simple. Inside the MSIX file, we talked about these footprint files. First off, there's the manifest file. And that's really, again, that declarative install. It's all the information that we need to go and install the application and includes information about the identity of the application. Next, we have the app signature. And that's what we use to understand if the app is trusted on the device. Based on the app signature, we check to see if that signature is trusted on the device. And, there's a handful of trusted certificate authorities that if you get your certs issued from, will just be inherently trusted. And we make sure only those apps are installed. So in the case that someone just self-signs an app and it's not trusted on your device, we won't deploy that because it's not from a trusted source from you. We also have our block map. Our block map is a hash of all the files in the package, and that block map is signed on that same app signature. So when we go and lay down those files on disk, we go validate the hash of all the files that we're laying down are the actual files that are being put on disk. making sure nothing was tampered along the way, ensuring that what the developer intended to be on the box is actually on the device. And then through all this, we use the OS to go and manage and install those updates. Furthermore, we have another concept within MSIX, which is really called the MSIX bundle file. This allows you to componentize your MSIX up and create a series of MSIX in a larger MSIX bundle file. The question usually ends up being, why would I go do that? Well, if you want to go and distribute your app, it's very easy that you can put multiple architectures within this bundle file, as long as, in addition to multiple resources. So now you can give your users or your enterprises one MSIX bundle file, and then when they go and deploy that bundle to a device, we'll detect the architecture that's relevant, and then we'll also detect any of the languages, or if you're doing things like for high DPI scale, that need to be deployed on the box, and only lay down the bits that are applicable for our users. So we want to make sure that we can give you an easy to use deployment technology, but also at the same time not bloat your users' devices. So it's a great way for you to go and break up your app and make it scale for many different scenarios. So let's take a look inside this manifest file I keep talking about. So this is just an example of our Photos application. And inside here, I'm going to highlight some key elements that are generally of importance for developers. So first off is the name. So this is just the name of your app. So in this case, it's Microsoft Windows.Photos app. And then we have the publisher. The publisher, is the person that's going and creating the app, but this publisher name also ties to the subject name of your certificate. So that's one way we can, really bind the identity of the application to a trusted authority, so that if I'm John, I can't just go out and say I'm Microsoft or Contoso or Fabricam. For me to actually issue this app or deploy this app and sign it, it has to map to my signing certificate. So we do enforce that, and it allows us to enable that authenticity of the application. We also have the version, so you can version however you want. And version is important because generally we just deploy version latest. We do have some opportunities to go and roll back in the case that you have a break and you want to roll back. But all in all, just populate your version, and we'll keep rolling that forward. And then architecture, x86, x64, ARM. And again, you can create one MSIX package for each architecture, and then put all of those into an MSIX bundle. The OS will detect the best applicable architecture to put on that device, and we'll deploy it to the device. And then lastly, the target device family. This has two key elements in there. The first one is the name, which ties to the Windows SKU or edition that you're using. So in this case, the Photos app is applicable on desktop, but it's also applicable for Surface Hub, which is the line below, which is Windows.Team. So if you're building an app that might want to be used across a couple different platforms, you can go and leverage the Windows.Desktop or the target device family to specify the specific runtimes or the platforms that you want. Now, if you're building a universal Windows app, you can specify Windows.Universal, and it'll apply to all the Windows platforms. And then we also have the min version field there as well. And that's applicability for the OS version that it's being deployed to. So if you were targeting something like maybe you're taking advantage of the 1909 build, and you wanted to make sure that this app was only deployed on those operating systems, you'd set that min version to the build number that is Windows 10 1909, and we won't deploy to earlier versions of that. So that was the manifest file, and in there I kind of talked a little bit about identity. So when I talk about identity in the MSIX world, one of the main things it's used for is identifying the apps that are installed on the box and how we process updates for these applications. So we have two concepts of identity. The first one is what we call the package family name, or the PFAN for short. This is a combination of your package name that I showed you in that manifest, which is your name. And then it's a hash of your publisher, because we don't want to have that publisher be really, really, really long. We're going to go and hash that to kind of go and simplify it. This identifies the entire lineage of your application. So no matter what version, what architecture, what anything that's being installed, it all ties to this entire family. And what's important about that is, as you're making multiple versions or potentially multiple architectures, this is what helps drive the upgrade path. Everything in the family will keep trying to roll forward to newer versions as those are targeted and applied to a device. Now, when you're looking more at the device and trying to really understand what's going on with an app on the device, that's where the package full name comes into play. Again, it's the package name. And now at this point, we incorporate version and architecture combined with the hash of the publisher. So this gives us a more specific understanding of what's going on with the device and lets me know the exact package that's on that device. So if I'm wanting to know, hey, are my users out of date? Maybe I'm trying to make sure a breaking change doesn't affect them, or God forbid, like a security exploit. You can go and look at the specific version that's being deployed on the device, and then know if the user is compliant or up to date, or maybe potentially needs an update. I'm going to pause for a sec. Okay. Cool. Next, we want to just kind of talk about, I talked a little bit about the tamper protection. Let me go into a little bit more detail of what we kind of do there. So, as I was saying, we have the signed block map, we have the signature, and then at app installation, we go and verify the integrity and authenticity of that package. When the app's been deployed, we periodically check the package integrity of that app. So not only after the app has been deployed, we can do ongoing checks to make sure that app hasn't changed. So if for any reason, maybe a file got corrupted, or again, maybe somebody has injected something into your file, we can go detect that and understand that the app has been changed or tampered. And then what we do is we put it into this last phase, which is called remediation. And what remediation does is it prevents the app from launching, and then it needs a repair. There's several different ways that an app can go and repair itself. If the app is coming from a Microsoft store, any app update or a Windows update scan will auto repair that. Likewise, if you're leveraging our auto update functionality that I'll talk about a little bit more in this session, we'll go and check for updates when you're looking for app updates to go and repair that application. And what we'll do is we'll go and leverage that block map, look for what is broken, and then pull down the differential changes to repair. So even in that case where the app might have been broken, we won't look to go and re-download the entire app. We'll just try to fix what is broken and bring it back to a good state for the end user. One important thing to think about with MSIX, as opposed to some of the other technologies we've done before, is really there's no limits on where you can go and distribute the application. You can distribute from any server that you want or any location you want to your Windows 10 device. So whether you want to host on a website, if you're hosting it on a UNC share, or maybe in an enterprise you're using something like Microsoft Endpoint Manager, you can deploy it to wherever you want. And you can deploy it to any edition of Windows that you want. So it's not tied to a specific edition of Windows. It's included as just a Windows operating system. We want to be no different than any kind of setup.exe you can build, MSI or script. So there is nothing that's tied to the operating system from a licensing standpoint. So wherever you can deploy your app today, tomorrow you should be able to deploy that same application. So let me now take you through a quick demo of how easy it is to kind of host your MSIX package from a website. So here I just have a typical Windows 10 device. And here I have a website here that's, for my Fabricam website. And I want to install our HeadTracks application, which is our HR application. And I can just go here simply and, click this button. It's going to say, hey, I want to open this application to go and install an app. The app installer is built-in UX to Windows that will go and be able to pull some information about the app directly from the website without having to download the entire application. So I can tell you information about who's the publisher of the app, if the app is trusted. This one in the case is trusted by Contoso, which is my enterprise, and anything the app is going to do from a capability standpoint. So like camera and things like that. I can easily just go ahead and click the install button here, and my app will go and install. Now, how does that kind of work on the back end there? Well, let me kind of just walk you through how easy it is to just host this on your own website and get that experience where I'm directly installing from the web. Here you can see the reference to my file. And what I did is I put this little bit of protocol activation in front of the link to my app, which is this ms-app installer source. And what that allows me to do is directly invoke that app installer app, which is used to drive the UX installation of an app. So in a traditional world where you're hosting your installer on a website, the user would have to go and download that into the downloads folder, go there and double click it and install it, really using kind of double the footprint, also taking all that time to download everything that's on the device. In this situation, I can just directly install it from the website. I don't leave that file back in my downloads folder, and I get the app up and running as quick as possible for my end user. And then you'll notice that in my file here, expand a little bit more. It actually ends with .app installer. I'm going to talk through that in a couple slides, but that's also a config file that you can host on your website with your MSIX package that'll allow you to go and drive auto updates of your application. So I'll talk a little bit about updating, and then I'll come back and explain a little bit more on how that app installer file works. So that was how easy it is to actually go and install an app from a website. So let's just talk a little bit more and recap some of the benefits of MSIX. Again, really, it's really all about never regret installing an app. We really want to provide a predictable, safe, and reliable deployment. And the best part about that declarative install is we know what we put down, so we know what we can pull off of the box, really getting you that clean uninstall of the application. We have lots of things in the operating system to optimize for disk space optimization. So things like, I talked about those resource packages in the bundle. So if you want to build for multiple languages or multiple scales, you don't have to incorporate that all into your package. And we can just deploy the files that are needed based on those resource packages. Also, we single instance files across users. So maybe you have two apps that are sharing common libraries. You can put each of that library in the app. And when we detect multiple apps have that, we'll go and just store it once on disk and link it over to the other application. And then lastly, we do a lot for network optimizations within the operating system. So first off, if a file is shared, like I talked about, we single instance it on disk. We also never pull it over the wire if you're installing, like I showed you in that last demo. Also, if you're doing an update, we take that block map that I talked about, which is the hash of the files, and we do a comparison of the old block map to the new block map and download just the changes at a 64K block level. So when you're doing an update to maybe a 100 meg app, you might have something that only has like a 10 or a 15 meg update. So you can really make it a faster install for your users and really minimize the impact to your end users. So when we think about updates, the core things to kind of remember are Windows controls the updates. There's not much you have to do for updates in your app. There are abilities that you have that you can go and force trigger things in the operating system. So maybe you just want to validate that the app is on the right version with your server. You can always go and talk to the platform and make sure that it's doing a check for an update. But all the updates are just automatically done based on that package family name that I talked about on earlier slides. Again, only the changes are downloaded. And we also have the ability to go and stage the files, install the files that are needed while the app is still running, so that when the app shuts down on the next launch, it'll actually change over to the newer version of the app. Unlike things like MSI, where when you go and grab that new version of the MSI, it might take quite a bit of time for that MSI to install, and your user is down for quite a bit of time. So we're really trying to optimize for what we're doing in the background and minimizing the impact to our end users. So let me walk you through a little bit of how these updates work when you're installing from the web. So first off, I have my original package here, and the package is installed on the machine for the first time. So in this case, there's no files on the device, and all the files are going to go and have to get downloaded and laid down on disk. At that point, the app is registered and ready to go. Now I've identified that there's a new version of an app available. And at this point, when we go and do the update, we notice that only a few blocks have changed, and just download those differences to the disk. At that point, what we'll do is we'll link over the existing files to the install. And then at that point, your new app will be ready to be registered and used by your user. And in the background, we'll clean up the old files that aren't needed anymore. So again, really trying to optimize the amount of network traffic we're doing and the amount of downtime for your users. And now the new version of that's available. So one of the common things we get is, hey, this all sounds really cool and everything. How can I better understand really what's kind of going on for my app and the deployment platform? And don't worry, we got you covered here. Within the Windows SDK, we have a tool called Compare Package. And this Compare Package tool allows you to take two of your existing apps, run it through the tool, and it actually gives you analysis of what's going to happen during an update. So this is the app installer app, the thing that I showed you that was that white UX when I'm installing apps. And I did an update last year, and I ran it through the tool, and this is kind of the output. Now that app in general is pretty small. It's only a couple meg, but we did some code refactoring and some other things. And you can actually see the impact is going to be the change that's downloaded, and then the size difference is any kind of growth on disk. So this gives us a really good understanding of how much, my impact from an update to my end user is going to be relative to what my real package is. And then also, just lets me understand on an individual file level what was kind of going on. And again, this is available inside the Windows 10 SDK. It ships there. It's been there for quite some time, I think, since 1607. So at any point, you can grab two of MSIX files within the same package family. And it also works for bundles, and you can use this tool to help you better understand that. So, app updates are kind of one of the more important things that, a lot of people kind of come to talk to me and ask about. And really, we want to make sure that in addition to the Microsoft Store, we have multiple ways to do app updates. So if you're leveraging app updates from the Microsoft Store, everything's just kind of handled for you. You ingest your app into the store, the Windows Update scan runs, and it's all kind of taken care of for you. When you're hosting outside of the Microsoft Store, we want to make sure we give you a few different switches that really help you empower you to kind of go and build and manage your application. So when you're thinking about deploying outside the store, that's where this app installer file comes into play. And I'll show you a demo of that in a moment. And it allows you a few different things. It allows you to go and configure silent updates that can just run in the background, similar to like a Windows Update scan. Every day at midnight or every 24 hours, we can go and scan the device, and then we just update the app. Again, not much for you to do other than to configure this configuration file, and the OS does it for you. But likewise, we can also let you go and configure checks on launch. And those launches, the checks can be a passive check where it just happens silently in the background each launch, or you can invoke UX to tell the user, hey, there is an update and you need to take the update before you can continue running the app. Maybe you had a breaking change on your service, and you want to make sure the application will still work, and you want to present UX to your user to let them know what is going on. So we give you a bunch of options there. And then likewise, I talked really early on about how when we're doing updates for packages, we always kind of move forward. We do have the ability for you to go and identify the ability to go backwards with an application. Now, this has to be an explicit call out as you as a developer, or if an IT pro is deploying this, to say, I want to go backwards. But in the case that maybe you release something that broke your users and you want to immediately get them back to a known good state, you can set this force update to any version flag in the file, and we can go take users backwards to the previous known good state. So at this point, let me transition and kind of show you a nice demo of how auto updates in action work. So I'm back at my device I was at before, where I had my HeadTracks app here. And what I'm going to do now is I'm going to go and actually publish an update to my app installer file. So let me first show you what the app installer file is, because I didn't go through that in the previous demo. And really, it's just this small XML file. It has some information about the file itself, which is the URI to the file and the version. And then information about your package. So, the name of the package, the version, the publisher, everything that's very similar to the manifest. Plus, most importantly, we have here a URI to the package that I want to go and install. And at the bottom, you will see update settings. So for the demo, I'm not going to have any time between checks. So hours between checks is 0. We really do recommend doing something like 24 or 48 hours because we don't want to constantly be hammering, network and servers for your users. And then you'll notice these two other things. The first one is show prompt equals true. That's going to show me a dialog to my end user, knowing that there's an update. And then there's update blocks activation. And that's another one that you can do true or false. So you can show a prompt to the user and let them take the update. And then you can decide if they don't want to take the update, if you'll let them proceed with the app. And that's what that update blocks activation equals true is. Maybe it is something that affects your service, and the app won't run, and you don't want them to try to get into a bad state. So you just prevent them from not running the app until they take the update. So I'm going to go here is I'm going to go to my server, and I'm going to upload a new version of this file. Okay, there's my new one. And then when I go launch my app again, we should see it go check for an update. You can see an update is present. So I'm going to go and take this update for my app now. And you'll notice the update is really, really quick compared to the initial install. And that's because it is just downloading those smaller differences of the file. And now you can see there's a couple new fields in my app here, and I have a newer version of the app. So just like that, from a dev perspective, all I had to do is post a new file to my website. When my users launched the apps, they were able to take advantage of an updated version of the app with very little effort from you as the developer on your side. So a couple of things that are kind of coming in the update. So what I've showed you is pretty basic support for it. What we want to do is actually offer more functionality, and it's things that we're working in the year to come. with MSIX. So the first thing is while the file is hosted on your server outside your package, we are looking for the ability to include that file within your package. So for folks that are downloading the app to a USB key, plugging it in and installing it, or things like that, maybe within an enterprise, we want to make sure that those can take advantage of updates. So we're looking at adding that. We're also working with a bunch of partners on allowing for some custom authentication, making sure that it can work with different authentication protocols, so that not all your apps have to be on an open server, and you can do things like support flighting in different types of rings, if you like, for example. We're also looking for better support for some of our offline and online scenarios. And then one of the last things is really, optimizing for service delivery updating. So how can we really make it a super fast iteration thing as you're working through Azure DevOps? So, the biggest question I get is, this is all cool. I have my app. How do I get to MSIX? And the easiest way is just leveraging Visual Studio. In Visual Studio 2017, 15.5 and later, or 2019, we do have built-in functionality. What you do is you add a Windows app packaging project to your solution. And that brings in things like a manifest editor, it brings in debugging, but most importantly, it brings in the packaging wizard. And that allows you, when you go and build, to create the MSIX package for your source code, and also has the ability to sign that package directly from Visual Studio. But we know a bunch of people are actually really kind of driving over to driving over to Azure DevOps. And we do have an easy way to integrate with Azure DevOps. And that's through the Windows 2019 payload within the hosted build agent. So if you go and add that in, it comes pre-installed with everything you need for MSIX, easily configurable via package creation in YAML. And it's super easy to sign your package. And at the end, I'll have a link to the MSIX website that actually has some walkthroughs on both of these on getting started with it. We also do have a sample out there on GitHub for how to integrate with the Azure DevOps sample. And the last thing I kind of want to talk about is really, what does it mean for extensibility with MSIX? A lot of people do things like custom downloads or chained installs. And, when we talk about MSIX, one of the things is it runs in a lightweight container. So what are the things I can do to actually extend my app beyond the container? And the first and easiest way is, just building with a container in mind. And in this case, we'll have a suite of apps. Generally you might have like a Contoso app that has HR, billing, and design. We want to make it really easy to do that, where the apps are easily deployable, where you don't have to deploy them all together. And you can also service them and update them independently. So what we have is a model called optional packages. I talked about the MSIX. These are additional MSIXs that can declare a two-way relationship with the main app, so that they know that they can all run together in a common runtime in a common container and work together as a suite. Each package can have its own entry point. So, if you want to be able to have a separate entry point for HR, a separate one for billing, a separate one for design, you can totally enable and do that, just like you'd have with any kind of traditional installer. When these apps are deployed, they can be deployed independently or as in a group. More importantly, they can also be uninstalled independently. The apps can be serviced together, but they don't all have to be serviced to the same version. So you have that agility of managing the components the way you want to do it, and giving your users the ability to deploy the components that they need on their device. Another model we have for kind of extending apps is app extensions. And this is akin to more of like the plugin model. This is a little bit less trusted model, where you can just say, hey, folks, here's a way to declare yourself as an extension for me. And then you as the developer have a chance to go and enumerate the extensions, have the ability to add the extensions. You can disable, remove extensions that are behaving badly. You can also manage, allow and block lists if you really want. Developers in control of everything that happens here. So very much like a plugin model, that allows a lot of flexibility. You don't need to declare a two-way relationship. People can go and author to build upon you. And it's very easy. It's really just done through that app manifest that I talked about earlier. There's two things that you need to do. First off, the host has to declare it is a host, and you declare a namespace for your host. So in this example on the left, you see the host app manifest. It's using the category, Windows app extension host. And then, obviously in this, it's photo extension is the name of my extensibility. And then on the other side of it, the person building their plugin can go and declare themselves as just an app extension. They link over to you with the same name, photo extension, and then you're able to go and enumerate, query, load, unload all that from within your app. So all that can be done from within your app. You can create, one experience for all your users there. Likewise, you can actually also be a host and an extension to another app. So if you want to have your app extend into somebody else's app, but at the same time host your own plugins, that's totally allowed to happen in the platform as well. Lastly, I just kind of wanted to touch on some of the companies that we're working with that are adopting MSIX. These folks have been great partners and have really started moving forward with MSIX and finding all the benefits for their companies and really embracing the new technology. We just want to reemphasize that MSIX is the deployment technology moving forward. It'll help you build fast, safe, reliable deployments for your apps, make your end user experiences better. Let me share a couple links with you that'll help you get started. The first one is to our doc site. Our doc site has walkthroughs on taking your existing app and moving it to MSIX, whether you're using Visual Studio or Azure DevOps, as well as integrating with many of the new features that I talked about throughout this session. And lastly, we do have an MSIX SDK that is open source on GitHub. The packaging format is open source, and we do have the availability to build extra extensibility on other platforms such as iOS, Android, or Linux. Thank you very much for watching. Be safe, and I hope you have a great day.